All right. Well, welcome everybody. Let's go ahead and get started. It'd be nice to see your faces if you can turn on your videos. There we go, and I'll wait for that for a second. We are a team from the Exploratorium Institute for Inquiry. And my name is Fred Stein. I'm going to let my colleagues introduce themselves. Please unmute yourselves.
Hi, I'm Michael Fairchild.
Lynn Rankin.
Kelsey Lipsitz.
And we're a group that does professional development around the state, and we're very eager to work with you today. We're going to do two activities that demonstrate two different kinds of hands-on approaches that you can do online. And because that's what everybody's needing to do these days, we hope that's helpful. And let's go ahead and share the slides.
Great. Yes, and I just messaged Lindsay. I don't have that capability right this moment, but I think I'll be able to shortly.
Yeah, once you get me to co-host, that'd be good. So I'll just we'll be seeing slides in a minute, but our priorities, again, we wanted to show you we wanted to try to keep science alive in these days when there's just so many difficulties to doing it, and to keep it fun and interesting. So to figure out ways to really leverage the engagement that you get from science in this online environment. So we will be doing two different kinds of approaches. One of them is, is with materials that you can find around your house or that kids could find around their house. And another is where only the instructor or the teacher would have the materials and can use your phone or another camera as a webcam to have the students tell you what kind of things to do and to be interactive in that way. And again, all this in light of NGSS is to be trying to learn from phenomenon, trying to figure things out. So we'll be using phenomena online in a variety of ways. We'll also be integrating a lot of language arts because that's important these days. Okay, next slide, please. We want this to be for everybody. We've tried to make an effort that the materials we use or the techniques are things that everyone would be able to have available. And one of the components of the program is we'll have you do some planning after you do the activities and see how you might do some of these activities in your own context. And when you do that, please try to attend to that they work for everybody that you work with. All right, next slide. Here's our schedule. We'll do about the first phenomenon about 30 minutes where we'll have you run around the house, get some materials and do some activities and then talk about them. The second one, again, will be about 30 minutes, and that's the activity where we'll be controlling the camera and the materials, but you'll be telling us what to do. And then about 20 minutes of planning and sharing at the end. It's really helpful if you, we have a survey for you and we're including that in the time for the session so that you don't feel like you have to stay later, and just please do it while we're in the middle of it. Okay, next slide. So a few things that are useful to know about when we're in the middle of our session. We'll be using a lot of these Zoom features. You may be really familiar with them, so apologize for that if it feels redundant, but on the far right, on the bottom, we'll be using the chat feature a lot, and so just find that and be able to write into it. On the left, there's a mute feature, so when you want to talk, you'll have to unmute yourself. And then there'll be a time later, Michael, should we do that now or later to have people rename themselves?
No time like the present.
Okay, what we'd like is to rename yourself. We're going to do this to have you get into breakouts for planning and grade level clusters. But go down towards the bottom there where you can find the rename pull down, and then start with either TK1 if you're in either TK, K, or 1, 2, 3, and 4, 6, and then put your name. And that way when we do breakouts, everyone will go into the groups that we've indicated. Again, TK-1, 2-3, and 4-6.
And Fred, just another quick tip for folks too, because we're in screen share, Another way you can find that option to rename yourself is just to find the image of yourself anywhere. If you scroll across, find the image of yourself and click on your own picture, and it'll open up that menu where you can see the option to rename.
Thank you. So I can hear fingers scrambling, but we'll move on while you're doing that. So next slide, please. All right, and the activities that we're doing here and activities that you can draw on to develop your own with the kind of approaches that we're sharing with you, these activities are called science snacks that the Exploratorium has developed. These are short, hands-on activities with very simple materials, and many of them are based on exhibits at the Exploratorium. For those of you who don't know what the Exploratorium is, it's a large hands-on science museum in San Francisco. And the teacher programs out of the museum for many years developed these activities based on the exhibits and other exciting hands-on science things. So they're really good in this day and age where we're just trying to do things with very simple materials. And we'll be drawing on 2 of them today. Okay, next slide, please. So let's get into our first activity. It's called Secret Bells, and oh, excuse me. And what you need for this activity, what we'll be asking you to do in a minute, is to find some string and maybe a pair of scissors to cut it, and then any metal objects. And so the easiest kind of metal objects, you can probably see on my little window here, is a coat hanger, a metal coat hanger. And what you do with these metal objects that you find is tie string to them. Maybe it's a good idea to stop the screen share for a second. Okay. And pin me. Okay. And once you've tied your string to your metal objects like this, put your fingers in your ears and then either swing the object at a surface like a desk, or do it with one hand, and with your other hand and with a partner, hit it with a pencil. And you'll be really surprised, I believe, unless you've done this before, about just how loud and how beautiful the noise is. So very simple objects are things like coat hangers or metal spoons or oven racks. And so what we'll do is have you get up, a wonderful thing in the Zoom era, and actively for about 10 minutes, gather your materials, and we'll put a timer up so that you can see when we're going to start up again, and then you'll come back. So next slide, please. And this will give you the prompts to think about while you're doing those activities. So we'd really like you to, if you have time, to besides just finding them and doing them, is to jot down really quickly how you would describe the qualities of the sound that you hear from your object. We'd also like you to think about, how's that sound getting through the string to your ears? How do you think that works? And finally, what science and education practices, science engineering practices do you find yourself using while you do this activity? So after the 10-minute timer winds down, we'll be asking people to share the objects that you used and and what they sounded like. And if people want to read what they've written, that would be really great. Okay, so can we set that timer to 10 minutes now? Yeah, all right. And go ahead, if there's any questions, just stick around, unmute yourself and ask them. But otherwise, please go on, find some metal objects, tie them up, listen to what they sound like, and then be ready to describe them and think about some of the practices you're using. All right. So nice. Well, I'm going to chat you, Michael and Kelsey. Can you chat two people at once privately? Okay, so I'll just thank you for all of your help getting ready for this. There's a little minor freak out about the other computer.
I think the ice balloon looks great now too.
I'm excited.
Hi, Fred. I have a quick question.
Yeah.
This is Maria. I'm wondering, will Twine work?
Twine will work, yes.
Great, thank you.
Perfect. I'm glad you asked.
And Fred and Kelsey, I'm assuming if folks put middle school or high school grade levels, should I just put them into 4-6?
Yes, please. Did people indicate they were middle or high school?
Yeah,
Okay.
a few.
Yep. All right. Well, good to know.
Fred,
Yeah.
just FYI, we've got 3 people in TK1, 3 people in 2-3, and 12 people in 4-6.
Okay.
Is that? I know it's not the ideal balance, but.
Mm-hmm. Well.
You can chat me if there's.
And I did notice the one RSP person. Where'd you put them? They were K6.
I put them in 2-3.
Great. Okay.
Just to try and balance those numbers out.
Try
So
to balance things out.
Yeah.
Well, good. And kind of an interesting test if they, we'll see how far they get with 12 people in 20 minutes.
Yeah, we could split that into 2 groups if you wanted and have them work in parallel.
Because we have such little time for sharing at the end, I think we'll just keep it. Well, can you do that easily?
I can certainly do it easily. I think we just need another copy of the planning template, right? Does that make sense?
Yes, that's exactly what you would need.
Yeah, let me go in there.
Thank you.
Fred, may I ask another question? It's Maria again.
Hello. Yeah.
Okay, so I'm a little confused. Your title, Secret Bells, and then the 1, 2, 3, 4. So it looks like we're just working with number 2, correct?
You're working with number 2 and the 3, the one that says make a stack and try it. That's to tie a string to your metal object. Put the string in your ear and then
I
either
did
hit the
that.
metal object with a pencil or swing it against a table.
Okay. Okay, gotcha. Okay.
And then 4 is during, these next 3 minutes to the extent you can, probably just one object. Think about how you describe the qualities of the sound and how you think the sound's getting through that string. And then if you can, what practices might you be using during that?
What does SEP stand for?
Science and education practices. That's part of the NGSS, things like asking questions and planning and carrying out investigations.
Okay, thank you.
Pleasure.
Fred, I wasn't in on your meeting about this. Are we facilitating these breakout groups or they're self-facilitated?
I think like yesterday, that worked so well. I and we'll have access to what they come up with in their Google Sheet. So it'll be, it felt like the right thing to do. So 2-minute warning in about for all those who can hear out there, in about 2 minutes, we'll gather back together and begin to share what you used, what you heard, and some of your ideas. Here we go, 1 minute.
Hey, Fred.
Yeah.
It turns out that splitting the 4-6 group would give us one group that's like perfectly balanced, but we could have one that is 4-6 and one that's high school.
Okay.
Would that work?
That sounds great.
Cool.
Because we weren't expecting secondary, but because they came, let's let them get the most out of it.
Cool.
All right, ladies and gentlemen, let's go to the next slide. And those are the prompts that we want you to share out with, but we'll stop the screen share in a minute so that you can see each other. And if there's anybody who would like to share what they found out, what they found for an object that was interesting, and then answer any of these prompts, what the sound sounded like, how did you describe it? And then any ideas about how the sound got to your ears. Let's save the conversation about the practices until another few minutes. All right, and if there's anyone who's willing to say it, just either unmute yourself and maybe raise your hand or say in the chat box that you're ready to speak.
I found 2 objects. I wanted to know what the difference was in having 2 different objects. And the bigger one had a deeper sound than the littler one.
Wonderful. Can you describe, was there any other qualities of the sound besides the deepness of the sound?
Whoa, describing the sound. Okay. It vibrated.
Okay.
Yeah.
Kind of like, well, wonderful. And so if you'd like, say anything about how you think the sound got through the string to your ear. Like, why was it so much louder through the string than just not through the string?
The sound is traveling through the string, around my finger and into my ear.
Neat. So all those vibrations from the object can travel through the string maybe a little better than through the air. Nice. All right. Thank you. Let's, anyone else can share their object and any of the descriptions of their sounds that they heard.
Well, I just had similar objects, a metal ruler and then a spoon. And the sounds are very similar to me with my hearing.
Okay.
And I think it's because the material seems very similar. They're very light, cheap metal. You know, the density of them is very similar, weight-wise.
Can you describe the sounds that you heard?
Yeah, so with the pencil, it was just the dull tapping. And then when I did do the string to my ear, it was a tinny chime. And that's the only way I could describe it.
Like a tinny chime. When I hear tapping, it sounds like you tapped it and the sound happened and then stopped pretty quickly. Is that how
Yeah.
it sounded? Or
Yeah.
did it go on for a long time?
Oh, with the pencil or with the string to my ears?
Yes.
Oh, gosh, I don't know if I was paying attention to that so much. I don't think it was long. It didn't last very long.
Okay.
Yeah.
Wonderful.
Thanks.
Let's have another.
I used a like cooling rack, little metal cooling rack.
Beautiful.
And when I tapped it with a pencil, it just was a short little clang kind of sound. Then it was short. When I put the string to my ear, and if I tapped it with my fingers, it sounded like you know, like a big church bell. Maybe the sound kind of continued and echoed.
Those are lovely descriptive words, and the reason I'm calling those out is these kinds of experiences can really lend themselves to descriptive oral or written work. And so descriptions are part of the Common Core kind of one of the text genres. And so it's useful to think about phenomena like this as promoting these kinds of descriptive words. Okay, if there's one more person who'd like to share their object, that'd be wonderful. And then we'll talk about these science and engineering practices.
May I?
I was going to, sorry, don't want to interrupt. I was just going to say it'd be helpful if people secured their video so it felt like the group. We could see the group.
I'm not sure what that means.
But so many people have their videos off. If they could turn their video on so we could see everyone, even if they're not there.
Thank you. Okay, that helps.
Sorry, I couldn't figure out a good way to say it.
All right.
Could I share about mine?
Yes, please.
Okay, I just wanted to add, because I felt like I heard a number of sounds, so I was wondering, I used a very similar cooling rack, but I wondered if, because there are so many pieces to mine, if I'm getting more of like a multifaceted sound. I'm an English teacher, so this is very challenging for me in a wonderful way.
And by multifaceted, you mean there are many different kinds of sounds?
Yes, there seemed to be. And the only thing that changed, so I tried the pencil after one of the other teachers shared that. And the pencil versus my finger, the pencil brought in higher and lighter sounds, whereas my finger brought a lower quality to what I heard.
And I'll just mention, thank you, that's helpful. I do think because your oven rack is made of lots of different pieces, that hitting different parts of it are going to make it vibrate in different ways and make different sounds. And so that's really interesting to think about, is just hitting it in different places and seeing how that changes the kind of sound. Because many people have tried both their finger and like a pencil, I want to make the analogy that a pencil is going to be better, because it's kind of like hitting a xylophone with a xylophone, you know, I forget what they're called, I'm blocking on the word, but they're usually made of wood or metal, your mallets. And if you tried to hit a xylophone key with your finger, it's not hard enough. It kind of absorbs all of the vibration. So hitting, when you do this activity, I encourage kids to do it with pencils or with swinging it and knocking it against a hard table, and then you get a good mallet effect. Okay, in about a minute, and please use the chat box for this and we'll call it out. Please write down what science and engineering practices you think you might have been using during the activity. And for those who need a reminder about what those are those NGSS, kind of the thinking skills that you use during science activities. And so there are things like asking questions or planning and carrying out investigations, explaining, interpreting and analyzing data, communicating results, things like that, and see if there's ones that you think that you're using. And we'll read some of those out, and if useful, we'll ask for elaboration. All right, would anyone like to say any out loud that they were doing?
Well, we were each conducting our own investigation.
And I see from Rachel that asking questions and defining problems and also planning and carrying out investigations. Can you say a little bit more about the asking questions part?
Sure. I guess like when I was doing it, I was asking myself questions like, oh, I didn't know that would happen. Like if you put your fingers in your ears, I wonder what's causing that, or how come my scissors sound different than my hanger, or what's going on there. And I can imagine that if you did this with kids, they would have similar things like, why does it, you know, if I tap this on the table, it sounds one way, but when I tie a string to it and put my fingers in my ears, why does it sound different to me? So I think there, and probably a lot more that I'm not even thinking of. Kids are curious about things like that. So
thanks so much for giving the examples. Those felt really like they would come up for most people. And then the lovely thing is it leads right into investigations, because then that's the basis of questions. All right. Is there anyone, before we go to our next activity, who's got one more idea about a practice they thought they were using? And it's okay if not. I'm using a little wait time, but I won't use too much.
Well, in terms of the experimental design, I changed the length of the string. I changed how I hung this thing. So yeah, inquiry experimental design.
Lovely. There's just so many quick things that you can do. And then you can imagine if you had a class, either synchronously or not, you could keep track of those, and then people could take ideas from each other in a way that's really productive. So thanks for that. Let's go on to our next experiment, and I'm going to turn this over to Kelsey to lead us through this.
Yes, great. Thank you, Fred. I'm going to share the screens again. So give me one moment. Okay. Great. Yes, so this next activity is one we call ice balloons. It's a whole group activity where the facilitators are the ones with the materials. So we think it's a nice model of an experience where only the teacher or only the facilitator has the materials, but the learners can still engage with that phenomenon. It's an activity that integrates ELA. So we know the Common Core state standards apply to students K-12 and particularly K-5 students spend a lot of time with the Common Core state standards. It also includes 3 kinds of writing genres, so narrative, persuasive, and explanatory. And in this activity, we're going to use science phenomena to support both narrative and argument writing today. So again, like Fred mentioned, this is also a science snack. So this is on the Exploratorium website as well. So you can find more information about how to do this on the website, and we'll provide that link in the resources at the end as well. But in a moment, I'm going to unshare my screen and we're going to take a look at this phenomenon. So ice balloons are just frozen water balloons with the balloon removed. And again, we're going to make some observations about those ice balloons, and it's going to help us write a narrative and an argument piece. So writing, of course, is a process, and breaking down that process can help support students in that writing. And one critical feature of narratives are descriptive words. So when we take a look at this ice balloon, I'm going to ask that you jot down some descriptive words as you're observing the ice balloon so we can use them a little bit later. So if you have a scrap piece of paper or notebook, if you could just jot down those descriptive words, that would be great. And then later we'll use those in our narratives. So Fred, if you have the materials ready, I'm going to stop my share so that we can see this phenomenon. Beautiful. And Michael, would you mind pinning that video so that everybody can see it pretty large? Awesome. And so the way we're going to interact with this phenomenon is if you just want to type in the chat box, or since it's a relatively small group, you could unmute yourself, tell us what you want to see and tell us how you want us to manipulate the camera. We can zoom in, we have a flashlight. There are a number of things we could do to observe this ice balloon. So any requests? Nice. No requests yet. So thanks for just zooming in a little bit, Fred. That's nice.
Mm-hmm.
Is it possible to go around this wonderful round thing?
Yes. It is a wonderful round thing.
Kelsey, I got a chat. I think it might have come to me privately, but they're asking if you can focus from above too.
Oh, great. Yes. Thank you, Michael. So maybe a 360 and then go above. That would be cool.
All right.
Nice. Okay, and that's what it looks like above. We're getting a little bit of a glare, but you can kind of see those. Oh, that's nice. That's a nice view. Great. We've also got a suggestion to turn the balloon or shine the light through it. Ooh. Yeah, that was an interesting. There you go. Thank you. Great. Excellent. And what about the light? Can we just get the flashlight to shine through it or in a different spot maybe and just see what happens?
Mm-hmm. And I have a large light on the top of a clamp light set up. I'm going to turn it off and see what that does.
Great. Okay, now, oh, interesting.
And so now I'm shining a flashlight through it.
Mm.
So I hope everyone's writing down descriptive words.
Yeah, if there are any descriptive words that you're particularly fond of and you want to share it in the chat, that would be great. We heard wonderful round thing at the beginning. Oh, there we go. Oh, that's cool, Fred. So that's a magnifying glass he's using. Ooh, lots of specks inside. Yeah, that's a great description, speckled. Great, very cool. Yeah, so keep jotting down those descriptive words. What we're gonna do next is actually try something different with the ice. Ooh, slippery, that's great. Thanks, Rachel. We're gonna try something new with the balloon. We're going to add some salt to it, and we're going to ask that you make some observations about what happens when we put some salt on the balloon. And we're going to use our observations of that to write a narrative about what happens when we put ice on the balloon. Great, thanks for sharing these. Ooh, rusted explosion of ice crystals within a translucent ice sphere. Shiny, nice, smooth. Great. So again, just continuing to jot down descriptive words, but also writing down some observations about what happens when we put salt on the ice balloon.
And here it comes.
Great. And I think we've also got a little bit of food coloring too. So if that's a little bit tricky to see, we might add a drop of food coloring. Thank you. Oh, now you can see. Great. So in a moment here, oh, thanks for zooming in, Fred. That's very cool. In a moment here, I'm going to ask you to write a narrative about what happened when we put salt on the ice balloon. And to do that, feel free to use the descriptive words you've been generating, but also just put your observations into a sequence of events. That's another key feature of narratives. Maybe as soon as you feel ready, if you want to start your narrative about what happens when you put salt on an ice balloon, that would be great. And then we'll share in a couple minutes. That's a great view, Fred. Thanks. Nice aerial view. Thank you. Let's take about 1 more minute to write our narratives about what happened when we put salt on the ice balloon. And then we'll see if we can share a couple. Great. I still see some of us writing, but maybe we could unpin the ice balloon image and go back to a speaker or gallery view so we can see one another once we share. But is there anybody who would be willing to share their narrative out loud? I'll use a little bit of wait time too.
I see some people are still writing.
Yes. Oh, and great. I see someone's used the raised hand feature, which is awesome. Yes. And can you say your name for me? I want to make sure I get it right. Anchi?
Sure, Antje.
Antia?
Mhm.
Great, thank you.
Yeah, just to give it a go. When putting salt on the ice balloon, an area of melting was created. The ice changed to liquid and was pulled by gravity, trickling down the sides. Food coloring made the course of water runoff visible. The runoff created a puddle around the sphere's bottom.
Great, nice, really nice sequence of events. It was very, very clear. Thank you. I like the use of the word trickling too. I could see that. Another example.
Okay, I'll go again.
Great, thank you. And tell me your name one more time.
My name's Deborah.
Deborah, thank you, Deborah.
Let me get my script here. Okay. About a tablespoon of salt was sprinkled on top, then some drops of food coloring. Melting had begun with water dripping down all over the sphere, creating rivulets and grooves. The salt at the top created a bowl. There's probably a better word than that, but a bowl at the top of the sphere.
Great. Yeah, rivulets and bowl. That's really nice. Thanks for adding those descriptive words.
Mhm.
Great. Maybe one more. One more. Oh, great. We've got one in the chat box. That's wonderful. The icy frosted sphere began melting very slowly as the salt and food coloring was placed on the top. Then it began melting down slowly like rain coming down on a giant crystal ball. When looking from above it, looked like a blue hole in the ocean. Wow, lovely. Really great descriptive words there. Thank you so much, Elena, for sharing. Great. I always love hearing these narratives because they're all so unique and really fun to hear. So thank you so much for sharing. We'll go ahead and move on just to have a quick discussion about using science phenomenon to support writing and how that can be useful. So let me scroll through a couple of my slides really quickly. So just take a moment to reflect on some of these questions. How do you think doing a science activity and then writing about it lends itself to writing narratives, and how might you support students in your classroom? And then Michael's going to drop a link in the chat box, and that document is something that Fred created. It includes the standards for narratives and argument writing at the elementary grade levels, and the parts in red are what we think are relevant to science. So just giving you a little bit of a reminder of what those standards are and how they might connect to science. So if that's helpful, you can use that. But let's just reflect for a moment and then we'll share some thoughts in the chat box. Great, we've got some comments in the chat box. Yeah, so one standard is a how-to, so this could work well for a how-to. Yeah, any other thoughts about how using science phenomenon might support writing or writing narratives in particular?
May I just share in speaking?
Yes, absolutely.
Okay, so I'm going to flip to my answers. So how do you support students writing narratives? I think one easy way would be just to let them partner, do a shared written response, and or partner and have one person write while the other person, one person speak while the other person writes and what they're hearing, if you've got students at that level. And then, so some easy ways so that it's less one person having to share out and feeling constrained and concerned about their own writing skills. Then how do you think doing a science activity and writing about it lends itself to writing narratives? This lets them understand that writing is a tool that we use across the curriculum and throughout our lives, rather than just in the English classroom, things like that.
Love that. Thank you so much, Maria. Yes, I think that idea of partner writing or collaborative writing is really, really great. And yes, writing is a tool across disciplines. Thank you. Yes, and
nice comment in the chat box.
Yes, thank you, Rachel. Yeah, struggled to come up with ideas, and by sharing some descriptive words, they have some tools to get started. Yeah, and from Elena, it's hands-on, so it's easy for children to understand those descriptive words. They have an experience to write from. That's great. Thank you. Any other last minute comments about phenomenon and writing narratives? And we can continue to drop those in the chat, but I'll go ahead and move to the next text type. So we're gonna use this phenomenon to write an argument piece as well. So just want to make a quick point about the use of the term argument. So the framers of the Common Core State Standards thought that writing genuine arguments is too complex for primary students, and they suggested that writing opinions might be a step toward that goal. However, the framers of NGSS firmly believe that primary students can and should engage in genuine arguments. So that's why we're using the term argument here. But there is a document that Michael just dropped in the chat box that further breaks that down a little bit and shares a little bit of information about that. So, and great, we're getting some more comments in the chat box. So thank you so much. That's wonderful. So we're going to go back to our ice balloon here, and we're going to see if we can answer this question. What do you think is inside the tubes? And when I say tubes, I mean kind of those specks that I believe Elena described in the chat box, so that you saw those kind of specks in there. And we're going to try to figure out what do you think is inside the tubes, and what can we do that makes us gather some evidence for that. So I'm going to unshare my screen. Yeah, Fred, do you want to make a comment before that?
And there's a variety of materials that you can ask me to use, including, I've got hardware, I've got tubs of water, I've got, you know, in the food coloring, and all sorts of things that, whatever you think might help you to see what's inside those, we can use.
Great. Thanks, Fred. And can we pin that ice balloon again? Great. Thank you so much, Michael. Yeah, so we'll use the chat box again. Anything you'd like Fred to try so we can figure out what's inside the tubes. And like you said, he's got hardware. So I believe that includes nails and a hammer and a screwdriver. So lots of things to try. Any requests or suggestions? Oh, okay. Yeah, and it's nice. You can absolutely share some predictions. So can it be air trapped? So how might we find out whether it was air trapped? What could we do to investigate that and to start to gather some evidence? Is it too soon to break it open? Great question, Craig.
Well,
what do you think?
We've got several more, so let me go ahead and break it open.
Nice.
We'll see what it looks like.
Great. We can't quite see the top, Fred, but what I assume you've got a screwdriver and a hammer or something. It looks too pretty. This is a pretty one.
I'll go ahead and break it a little bit more, and
Great.
so it's about in half, and see what that is.
Oh, nice. Thank you.
All right. Now let's get a close up.
Great. Yeah, and anything we want to do or try with that half broken ice balloon to try to figure out what's in those tubes. Add food coloring. That's a great suggestion. Fred, can we add a little bit of food coloring to that?
There we come.
Great, thank you.
And now just to see, I'm going to wipe it off with the paper towel and see if it all just stayed on the surface or if some of it got inside.
And Drew was also wondering if we could have a little light, and actually where you have it now, you get a little bit of light there. Yeah. What about a nail or a pin? Do you have a nail or a pin, Fred? I'm wondering if we could try to poke one of them.
I do. So let me see if I can find a place where one of those tubes is like right on the surface there. There you go. So I've now put my pin Let me do that again.
Yeah, that was great.
Inside one of the tubes, and it went in for about, oh, I don't know, about a half of a centimeter.
Okay.
And it's funny, when I find the place, there it is. On the surface, it's very, you can't see much there with my hand in the way. On the surface, it's very hard for me to poke it in, but when I get to a hole, it actually goes in a little bit.
Okay. Yeah. So what would that, what evidence does that provide for us? So we had a prediction that maybe it was air trapped. Does that help us decide what might be inside those tubes? Is there anything else we want to try to challenge our predictions, confirm our predictions? We also have that tub of water, if we'd like to do anything with that. Create some cracks, yeah.
And I just want to zoom in on one little feature. There's a place where the food coloring, let's see if I can get this, created these little spots. And do you see those little dots? That's now out of focus, but those little dots are places where the food coloring sunk in a little bit into the tubes.
Great.
So that was a neat approach.
Thanks, Fred. And then could we place it in the tub of water? We've got a request to do that.
There we go.
Is anybody noticing anything? Yeah, there you go, Fred. I'm certainly seeing some bubbles or something.
Sorry, when I move right, the camera goes left, so it's a coordination issue here. And I'm trying to zoom down right on the edge of it.
Great.
And tell me if you can see anything.
Yeah, great. We've got another request to hold the balloon down a little bit.
So now it's completely underwater.
Yeah, there you go. Starting to see some bubbles come up. Yeah.
Zoom out.
Great. Thanks, Fred. Awesome. And while we're looking at the bubbles, maybe let's take a minute to see if we can build an argument. We might not have a ton of evidence yet, but we've got a little bit of evidence. So can we construct an argument about what is inside the tubes? And if you could put that in the chat box, that would be great. And then, yeah. Oh, interesting. So from Elena, we've got that when the balloon was tied, there was air pockets that created those specks. Great. And yeah, what evidence have we been able to collect that might support that it's air pockets?
And let's unpin the camera now.
Great. Good idea, Fred.
Thank you. Michael, can we unpin the camera?
It's unpinned. It just stays in speaker view after you unpin until someone else talks.
I see.
Yeah, and thanks, Fred or Craig. We've got some evidence in the chat box, so it floated in the water. Might be some evidence that there's something else inside the ice balloon causing it to float. Any other evidence that we were able to collect to support an argument that it was air? Yeah, food coloring went into the specs. So food coloring went inside, so it was maybe hollow. Air bubbles were seen coming out. Nice. So that's a great piece of evidence. And if we're not sure right now, we're not convinced from our evidence, that's certainly a reason to continue investigating. For time purposes, we won't do that today. So thank you so much for offering your evidence and your arguments for what's inside the tubes. I'm going to share my screen one more time, and then we're going to get you into some planning groups so you can think about how you might be able to use these experiences in your own settings. So just one more quick opportunity to add anything in the chat box about how doing a science activity like this lends itself to writing arguments. So there's that same link in the chat box, but any comments about how doing a science activity lends itself to writing opinions or arguments? So Elena, I'm wondering, is your question about kind of like science content? What is it that children will learn? Yeah, from a scientific standpoint? Yeah. Yes, okay. So I'm trying to think of a specific elementary grade level standard. But we use this activity primarily for supporting those science practices and that connection to ELA. So I definitely think there's some science content probably more appropriate for middle or high school, but I think this is a really, really nice activity for focusing on particular science skills and for supporting writing.
The actual science behind why salt melts ice and why the ice floats in water even though it's so big and heavy, and why those tubes form in a freezer are all able to be explained. And in the snack write-up itself, there's some of the explanations for some of those ideas that if you want to pursue them, you can. That's great.
Yeah, and we've got a third grade standard around density would certainly be appropriate. Nice. Great. Well, thank you so much for all those comments. So now let's go ahead and get you into some grade level planning groups. We're going to spend just about 20 minutes or so in these breakout rooms so that you can think about how you might plan an online lesson based on today's experience. And we've got a couple other questions that you're welcome to consider in those rooms. Michael just dropped a link in the chat box, and that's going to take you to a folder that includes some planning notes documents. And you already indicated which grade level group you'd like to be paired with. And then based on numbers, we might have moved you a little bit. But Michael's going to move you into those breakout rooms. Definitely click on the link now so that you're able to access that folder when we get into our breakout rooms. And then once Michael moves you there, you should have a, it should tell you which particular grade level group you're going to be working with and in. And then we'll come back for about 5-10 minutes or so to do some sharing and then end our session. So any questions about planning? Great. Okay, Michael, we might be ready for our breakout rooms.
Great, great. And like Kelsey said, you'll see the breakout, the grade level you're assigned to when your breakout room opens. And we have 3 breakout rooms, a grade 2-3, a grade 4-6, and a grade 7-12. So I'm going to go ahead and open those rooms now, and it'll move you into them automatically.
Can I say something first quickly?
Sure.
When you get into your breakout room, see if somebody would be willing to represent your group when we come out of it to share with everybody else, just any highlights for about a minute or two. And we'll give you like a 3 to 5 minute warning when it's just about, getting towards the end of time, so you can kind of collect your thoughts about how to share what you did. So also let us know, is there a way to do that if you'd like to talk to any of us during your conversation? Just put it in the chat box, I suppose, is the best way.
Yeah, there's a little ask for help button. I think it's on the lower right when you're in your breakout. You won't see it now, but when you're in your breakout, it'll give you that option.
Wonderful. All right.
All right, here we go. Welcome back, folks. I think we've got everybody back in the main room.
Great. Thank you so much, Michael. And I just want to thank everybody so much for the planning you did in your breakout rooms. We realized it might have been a little tricky to refine those prompts and your planning notes, but it looks like everyone was able to do that. So thank you so much for doing that. We wanted to hear from each group just a couple highlights from the conversation. So is there any group that would be willing to get us started, just sharing a few things that came out of their breakout room?
Okay, secondary school will start first.
Thank you, Deborah.
So we were looking at the possibility of drawing from many resources in teaching, or just providing one resource or source for the students when they're doing it. The lesson, the possibility of creating a video using a slideshow. Talked about the different hardware, webcam with video and all that. Having the students finding things at home is certainly a great way of providing a writing possibility for them, and mixing science and writing. And then we were talking about the math part, looking at time, looking at what kind of measurement that can be happening, and then graphing. Doing the teacher providing one experiment and the students doing another one, doing the next one. And then the whole teacher thing we're all looking at. How do we weave the background knowledge that we know that we want them to discover in the lesson.
Great. Thank you so much, Deborah, and the high school group. Anybody from 4-6, or I think we had TK3 in a room together, TK through 3 in a room together. So anybody from those groups?
I think for the younger grades, a lot of it is just the experience itself. And so even if we're doing it online, we would want to be, facilitating kind of like what we did today, and doing that with the students, letting them see that, and then, maybe using a chart to do some sort of brainstorming, what do we want to know? What do we want to see? And also using it as an inspiration for writing, going through the describing words and making that list for them. And then especially, for like third grade, they would be able to then take all those describing words that we brainstormed together and then go and do their writing and turn it in later. So those were some of the ideas that we talked about.
Great. Thank you so much, Sheila. And then last but not least, the 4-6 room.
Hi. So I think we had a little bit of trouble kind of getting it together to finalize things. My thought was, coming from a language arts, social studies background, I love the idea of even using the frozen balloon activity with my students and having that interaction and engagement, and how wonderful to enrich their vocabulary by looking at descriptive words, and then looking into using support to support the reasoning, through these. So it's so rich in so many areas for language arts. So using that cross curricular, even if I step on science toes, and then just so I think there's so much you can do with that, and having them engaged, or going around their homes to find an object like a scavenger hunt, and coming from an archaeologist perspective, like, okay, if you're in the future, what is this object? You have to describe it, and then come up with an idea of what would it have been used for, and so just doing creative writing, but having that narrative too, by using the actual object, but having them engaged in moving around their houses to find something. So, I mean, other people had other ideas, and that's just what came to my mind. So, thanks.
That's wonderful. Excuse me. Thank you so much, Heidi. I appreciate it.
No problem. Thanks.
Great. Okay. Any last minute comments or ideas? Okay, that's great. Thank you so much again for planning in these groups. I know not everybody knows each other too, and we have a short time together, so we really appreciate that. And then the last little bit, we've got about 5 more minutes, and some of that will be used for a survey. We would love feedback from you. But Michael has just dropped a link in the chat box that is a link to our resources folder. So we'll continue to populate that with the slides from today, and then there's, of course, the snacks on the website, the planning documents that you started today. So those are all going to be available to you. And then with the last 5 minutes, we'd love for you to participate in a survey. And Michael just dropped the link to that in the chat box. This online world is still experimental for us as well. So we really, really value your feedback, and would really appreciate if you would spend this last few moments together filling out that survey. And I think with that, I'll just say thank you again for joining us. And yeah, we just really appreciated spending the last hour and a half with you. So thank you.
Thank you.